Everybody, I was hoping a little more air conditioning, but welcome to the talk I'm giving on behind-the-scenes look at developing forced induction for the Miata. My name is Keith Tanner. I'm one of the owners at Flyin Miata. I've been there for a little while now. I also, behind the camera, we also have Brandon Fitch, who is actually the head of our R&D department and the lead engineer on this project as well. So nobody knows this better than he does. I'm going to fake it, but if I really get stuck, I'm going to throw it over to Brandon for the really hard questions. So this is going to be a generalized look at what it takes to develop forced induction for the Miata. I'm not necessarily going to be talking about this kit specifically. I'll be using it as an example, but don't take it purely as an ad for the new NC Turbo kit from Flyin Miata with carb approval that's coming out in early 2025, starting at $49.99. So. NB2? ND2. We're talking about this kit at the moment. We will not be talking about future products. I am going to apologize in advance. I do not have a lot of audio-visual things to show you. I was hoping to show you all sorts of cool 3D scans and some 3D models and pictures of the projects in development. Unfortunately, due to some software fights, we were not able to get the 3D scans in a form you could see them. We left all the 3D parts behind. And it turns out we took no pictures during development that were worth saving. So they're all pictures of somebody holding up a hose and then pointing at something. So sort of visual notes. So I'm gonna wave my hands a lot and try to explain it to you, and hopefully we'll get the message across. If you have any questions when we're doing this, please put up your hand. It helps direct where things are going. Usually when we shoot one of our live videos, it is not in front of a studio audience, so this is actually quite a treat. I like having people in the room. It makes it a lot more fun. So if you have questions, throw them out there. We'll use it to help direct where this goes, and hopefully you'll get more information out of it. If you're one of the people watching on the internet, please put your questions in the comments. We will do our best to answer them live. If we don't answer them live, we'll answer them in the comments later, because we do read all the comments for all of these. So, forced induction. Of all the products that we deal with for Miatas, this is the most complex. It's got the most parts. It involves the most parts of the car. It's got the worst packaging. So the project of putting together a good forced induction kit is a long one. We're a long way past the early days when you would just weld up a manifold, stick a turbo on something, crank the fuel pressure up, and see what happens. That was a technique 25, 30 years ago, but these days we have to be a little more scientific about it for multiple reasons. First off, it starts with a project meeting. We have to figure out what exactly are we trying to build. What are the goals for this? What requirements do we have? For example, with this one, we wanted to have carb legality. Obviously, it's very important to those of you who live in California, but it's also important to all of us. It shows the EPA that we are being good stewards of the environment, that we are not going to get in trouble for violating the Clean Air Act. It keeps all of your air around where you live clean, which we like. And it also means that there's no concerns about hassles with emissions. No worry about having to get a hot smog and worry that you're going to get pulled over on the side of the road and have your car impounded because it's not really legal. So carb legality is an important thing for us. And that, of course, complicates the entire process, but it also forces us to take a lot more things into account. We also take things into account such as how easy to install or to maintain. And then we have requirements that come out of that, such as we have to keep the stock catalytic inverter in the stock location. What does that mean? We want to keep drilling to a minimum. What does that mean, et cetera? So we spend a lot of time on the planning stage because that's where it's easiest to make big changes. Before you've actually bent any metal, before you've actually built something, you spend a lot of time thinking about it. So we spend a lot of time brainstorming. Should we put the turbo in the rear, do a rear mount turbo? Well, it's been done. It's got some downsides, it's got some pluses, but what the heck? Let's throw out the crazy ideas. What if we put the turbo somewhere else? What if we didn't do an air-to-air intercooler? What if we did air-to-water? What would that mean? What would that do? And so we spend a lot of time trying to think of, what decisions do we want to make? And when we come up to a certain direction, saying, okay, it's going to be fairly traditional in this case, we can move forward. And the next step is to obtain a car. It sounds like a trivial step, but you can't do anything until you actually have a vehicle to work from. And because of the way that emissions tests work, they usually test the worst case scenario, which is the newest option at the highest boost level. So you have to have a fairly new version of the car available to test. Easy enough with the NC, harder with the ND because they're still making them, so what's new is this year is not new next year. So that explains one reason why the ND programs are a little bit behind, because we're waiting until things stabilize in the ND world. Once we've got that done, we start doing 3D scanning. And this is where I'd love to have some beautiful 3D scan pictures to show to you, but unfortunately that didn't happen. But basically we end up with 3D models of the engine bay, we end up with 3D models of the engine, of all of the various hoses, all of the various brake lines, hard points that we have to take into account. And then Brandon and Kyle are two current engineers, and we are, by the way, looking for another mechanical engineer if anyone's looking. Norman, I see you back there. If you have any experience with Miatas, Norman, it would be fun to have you come by. That's when they start playing in the digital realm, and they start designing everything digitally. Starts off very crude, sort of blocky things, getting basic blocks in place, and then we start refining the designs. And we have models of some of these things off the shelf already. Garrett, for example, was able to provide us with good models of the turbocharger, so we knew exactly where everything was on that. And they start working on actual locations, which brings us to the next step, which is 3D printing plastic parts. And this is where I show you the large table full of interestingly colored plastic parts that we went through. But the advent of 3D printing has actually really improved the way that we can build these kits. When we designed the current generation of the NA and B kits back in 2006, we actually did 3D print a couple of the parts, the turbine outlet casting, the manifold casting. It was very expensive. We had to send out for it, but it allowed us to do the initial test fitting. In this case, 3D printing is cheap, it's fast, we can do it at home. And so Brandon and Kyle spent a lot of time basically working through revisions. We had a printed turbo because they're considerably lighter than real turbos. We print an exhaust manifold, we print the downpipes. And you can just imagine, those of you who are on this side can't see it, but trying to come up with the shape of this turbine outlet casting, get it right the first time, not an easy challenge. I'm sure there are some guys who do this, work for Ford, for example, could probably bang it out the first time, but we don't. So it took quite a few revisions to get the shape of this right. But because of the 3D printing, we were able to print it out, try it, and say, no, this needs to be over here, this needs to go over there, this needs to be a little bit thinner. Print it again, try it, print it again, try it. And those prints were at pennies per time. So it's a great way to actually iterate through the whole thing. Love my notes over here. So the design work, we work on the order of dependency. There's some stuff that is critical that you need to know right away. And I'm talking specifically about turbo kits, but this also applies to things like supercharger kits. And honestly, it applies to just about any design program that you work your way through. But on a turbo kit, for example, it's all about where does the turbocharger sit, because everything is attached to the turbocharger, everything's related to the turbocharger, and the position of the turbocharger is determined by the manifold. So the manifold is one of the first things that needs to be nailed down. That's where we spend the early development time, is getting the manifold right, getting the downpipe right, and those are also, happily, the two long lead times for production. So we get those shaped, we get them located, we get them locked down, and then we can start moving on to everything else. Intercooler location is obviously an important one as well, because all these pipes have to be designed for the intercooler. And that also allows us, when things are signed off, to be able to send off the CAD models for the finalized parts, if they are finalized by that point, to start production. Generally not quite yet. We're not there yet. So once we've got the hard points set up, we can start working on fluid and ancillaries. There's a lot of parts involved in a turbo kit. I've just got a quick list of various things that we had to take into account. And these are more or less in the order that they have to be figured out. There's the manifold. The catalytic converter had to stay more or less where it was. The outlet, turbine outlet, which is that crazy looking thing coming off the back. The intercooler, the pre-turbo intake, this little guy here. The hot side intake piping, the cold side intake piping. The turbo water supply, the turbo return, the heat shielding, and many, many, many brackets. If anybody here has watched Project Binky, we do brackets like Binky. There's just brackets all over the place that are involved here. So one of the things that we do, going back to this manifold and downpipe, these are critical parts to a turbocharger because you want to maintain as much flow as possible, as much energy as possible into the turbo, because that's what powers it, what allows it to compress air and ram it through the intercooler into the engine, and explosions happen and everyone gets happy. the flow through this is very important. So we not only design it to actually fit in that place, but we also try to design it to optimize the flow as much as possible. We'll use CFD, computational fluid dynamics, to model the flow through things like the manifold. If you see our new turbo manifold for the NA and B that we have down there, that has improved its flow by, I believe, 23% over the previous generation, which was done without CFD. This one we did some CFD on it as well. The cross section of this is designed to increase all the way down, even though it's got these weird little squeezes in it. That's to allow it to expand and continue to push through, or continue to encourage the flow, shall we say, of the air coming out of the turbine, because this thing runs on pressure. High pressure here, low pressure there. So the sooner we can evacuate that air, the better it works. So a lot of time is spent in the digital realm getting this right. Do we have any questions yet? Well, you're either all baffled or you're falling asleep, one or the other. Okay, so, yes?
You said a lot of this, especially with digital modeling, is based off those hard points you get from that one NC that you chose to be your development car. How consistent is Mazda with those cars? Are you...
Mazda's pretty consistent. And the good thing with the NC, it's a platform that we know all of it. And we actually have multiple NCs in our development fleet. So we know what changed over the years. But yes, the actual production, we try not to use up the tolerances so tight that the difference in welding or the tolerances that are in, say, the frame, the unibody construction are such that they would get in our way. We have to leave ourselves a little bit of tolerance. We have a close friend who is actually a packaging engineer, I believe, at Ford. Is that what he was?
I think so.
And he helped us by giving a little bit of backdoor information on things such as what they consider to be safe tolerances for hot things like turbochargers. And we violated every single one of those because we don't have the luxury of being able to design the entire car around a turbocharger. We have to start with a car that was designed without one in case. But we used as many of those guidelines as possible, taking into account the fact that engines move, taking into account the fact that things grow when they get hot. When they move, they sort of squidge around. So we do have to take a lot of that into account. But car-to-car variation, Mazda's pretty good. That's why your alignment still works, even though you've only got that little bit of adjustment. The alignment still comes out about right. So same deal. So one of the next things we'll do is we want to get these on the road. We want to actually try them, get them running. And so this is another place where modern technology comes in handy, and we'll actually get metal printed parts made. In this particular case, this outlet casting is not a casting. This is a 3D printed stainless steel part. And it's unbelievably smooth. I want to pet this thing. It's so smooth to the touch. But we had a couple of these made. We had a couple of manifolds made. The manifolds are too big to fit on that particular printer, so we had them made from, I think, 3D printed sand casts. So they came out looking like regular casts, but they were one-off molds that were used for that. And we machined them, and that was allowed us to bolt a car together and actually start driving. And that is, you cannot believe what an advancement that is from the good old days when we had to deal with wooden mock-ups and nothing actually ran until you'd made the investment in molds and you had your fingers crossed. So these 3D printed parts, we can fake our way through things like intake piping, because you can use 90-degree bends attached together with silicone couplers, and you've seen eBay turbo kits. I mean, that's kind of what it starts off looking like. But you've got to get this part right, and the ability to be able to 3D print that and get these on the road is absolutely fantastic. And I think we still have one of those in use, don't we? I mean, that particular one's been across the country a couple of times. Is that the one off Nancy?
The outlet?
The outlet, yeah.
Yeah. And both of the manifolds are still being used, I think.
Yeah, both manifolds are still on cars. That outlet has been across the country several times, and a whole bunch of dyno time and a bunch of track testing time. So that particular 3D printing is fantastic stuff. Yes?
Yeah, remembering an old cheap bell kit that I was almost given back in the day, I had to make a wrench to get out some of the nuts and bolts on there. I'm assuming you guys also take that into consideration, access to nuts, access to bolts?
So the comment, for those of you who are online and didn't hear the actual question, this fellow was the victim of an old Bell engineering kit back in the day, which they were a little crude. And one of the problems they had was access. You had to make special wrenches to get to some of the nuts and bolts. And so we had to install a bunch of those as well. We definitely took that into account. Does this one have any? It doesn't show up so much on this one. We did make sure there was enough clearance on the inside of the runners to actually get a nut and bolt in there and your wrench. On some of our newer manifolds, some of the other manifolds for the NA and the MB, they've actually got grooves in them so you can get a socket in there as you can actually tighten things up, because we have to install these too. Lessons learned, let me tell you. So we're at the point where we're actually out there and testing cars, and this is where we can start refining a lot of the design. Once we've been out there and we've discovered, okay, it's running okay, oof, that's good, we can start working on fine-tuning the design of these hoses. These silicone hoses are great because they can be made to very specific dimensions, very accurate dimensions. The folks who make these for us are really, really good at it. They're good to work with, and the nice thing is they've got a little bit of flexibility so that it allows the engine to move relative to the intercooler. It makes it easier to install because you can kind of squish things into place. There's fewer failure points than having a whole bunch of steel pipes stuck together with silicone couplers, as you may have experienced with that old Bell engineering kit. So we spend a lot of time starting to design custom hoses. And it's not just for the big air hoses that you can see here. I don't have any with me, but things like the water lines that we're running back here, they're all custom formed silicone hoses, and a few other various hoses and bits and pieces around. And one of the things we also did as part of that, now that we've got a car up and running around the track, is we started working on the cooling system as well, making sure that the cooling flow is correct. There's a lot of science to cooling a turbocharger. It's not just a matter of blowing a bit of cold air or a bit of water into it and hoping it comes out the bottom and everything's all right. There's thermal siphoning happens after the car's been turned off that actually keeps the turbo from coking its bearings. And you've got to make sure that you're putting that hot water from the turbo back into a good place in the engine. And this is where we take advantage of years of dealing with turbo Miatas on the NAs and the MBs, what we've learned about their cooling systems. And also we were lucky in the case of the NC, is that Mazda, or Ford, actually made a turbo version of this engine. This engine is also known as the EcoBoost. And so we definitely cribbed from their notes on the EcoBoost, spent a lot of time looking at pictures of EcoBoost and saying, okay, they're using this fitting right here. Water's going in there, figuring out the routing. And we actually made a couple of custom fittings to allow us to tap into various spots that aren't really available on the Miata engine, but might have maybe happily had a nice freeze plug left in place, for example. So that's our first install. We're gradually improving it. The car's out running around on the track. We're getting data. It's instrumented out the wazoo so we can figure out what's going on. At that point, we build a second car. And that one is given to the calibrator. And this is the fellow who does the actual engine tuning. And depending on the model of the car, NAs and MBs, there's a limited amount can be done with that. NCs and NDs, we can actually do a surprising amount to change the stock tuning of the tuning of the stock ECU, which many of you already know, because you've probably got tunes in your NDs and NCs already. So we work with, well, in this case, we worked with Calibrated Success, Greg Banish, who is a fantastic calibrator. He works with OEs. He's worked with a number of the other big aftermarket companies in other spaces. He's got a lot of experience in emissions calibration as well. So we sent it to him out in Detroit, and he took that car and started testing it on 5 gas analyzers to make sure the cold start and everything were working the way they're supposed to. He did dyno testing on it. He drove it to cruise-ins because he kind of liked the car, and spent a lot of time fine-tuning the calibration. That's the key to making these really, really work well and to make them clean as well. It's not just a matter of keeping them from blowing up at full throttle on a dyno. The hard part is cold starts, it's AC compensation, it's how it behaves when it's outside its normal operating parameters. There's a lot of important tuning has to be done there, including things like making sure the catalytic converter temperature comes up where it's supposed to, but also is maintained where it's supposed to. Catalytic converter temperature is a big thing to passing emissions and keeping your cat happy and healthy. So we had thermocouples, well, I guess thermocouple is the right term, in the catalytic converter to measure the actual temperatures in the cat. And we had, well, if you look at Nancy, which is the blue test car that we have in our booth right now, you'll see that there's still instrumentation all over that thing. We had engine bay temperatures, we had temperatures, intercooler, inlet, outlet. We had pressure taps on the manifolds. We had temperatures coming out of the turbine, I think, or pressures coming out of the turbine.
Yeah, we had temp and pressure on both sides of the turbo, both sides of the intercooler, and after the air filter.
Okay, so pressure and temperature, both sides of the turbo, both sides of the intercooler, and the air filter. Yeah, to try to figure out what's going on, because that's part of getting it right. And so we spent a lot of time going back and forth with Greg, comparing notes. He'd ask us to test something because, of course, we're at 5,000 feet of elevation. We can easily get to 12,000 feet of elevation. He's down at sea level. We were able to do a lot of altitude compensation stuff, which is a big advantage for us because otherwise it's a lot harder to do. All right, so there's our second install. The second install is also used to write the initial instructions because this is important to our customers. I mean, it's not just a matter of making this thing. You've got to be able to support it, got to be able to help people install it themselves. So the first round of instructions were done on that second car that was being built. And then we went through all of the instrumentation, logging, testing, cold starts, dyno, et cetera. Now while this is going on, now that we've got a draft of instructions, we can actually start the paperwork for the CARB EO. Because one of the things you have to supply with them is not only a whole bunch of technical information, but also part numbers, bills of materials, and instructions. So those instructions are also important so we can get the fairly long process of getting a CARB EO in place. We can start giving them their paperwork. They can start working through all of their backlog and asking us questions and back and forth, back and forth. So while all this is going on, we keep working on durability testing. We take the car, we've literally driven them across the country a couple of times. We were trying to count how many times Nancy has driven on 1,000-mile plus road trips. It's at least 5 so far. Yeah, some of them were considerably longer than that. We take them to the track. We take them to High Plains Raceway, which is a high-speed track similar to this one at high altitude, so it's really stressful on a cooling system. Has some nice long straights on as well. It's also hard on brakes, but we're not worried about that today. And the nice thing about High Plains is it also gives us the ability, it's a fairly open track in terms of access, so we were able to do 45-minute plus sessions and just pound on it, pound on it, pound on it. We also work with our local track, Grand Junction Boner Speedway, which has a lot of high load, low speed stuff where you're accelerating, braking, accelerating, braking, accelerating, braking, but very little cooling airflow. So again, we get to hammer the cooling system. We get to do big heat cycles. We can run it for a little bit, park it, let it soak, run it again. And this is the durability testing that we do to make sure that when we send this out to our customers, they're not going to come back to us with stories of cracked downpipes, exploded catalytic converters, failed joints in various places, et cetera, et cetera. Okay, so while all this is going on, we start signing off on some of the parts. For example, that manifold. Okay, we've been proven that the manifold is correct. It's in the right place. It's working. It's a long lead time product. We can't change it now without changing everything else. So at that point, we can actually start moving some of the parts to production. This is a challenging thing, trying to decide, okay, when are we going to let our baby go? If we make this commitment, we're going to order 100 manifolds. We're spending tens of thousands of dollars on manifolds and molds. Are we good to go? Okay, we're good to go. This is the scary step. Brandon didn't like it very much, but it is something we had to do. And this is the point where we start signing off on those things. Some things, like these flexible hoses, can be done much later because they can be mocked up and molded much more quickly. But hard parts like that, the cast stuff, takes a lot longer. And I'm going to mention one thing that just the sort of details that you come up with when you're working on this. When we were working on the MAP sensor, for example, or sorry, the MAF, the mass airflow sensor. On your Miata, it's a little plastic tube that goes into the intake manifold. On this one, we put them on a flow bench. We wanted to make sure we had nice, clean laminar flow through there because you don't want a bunch of turbulence. You want very clean signal from your mass airflow sensor because this is where all of your air-fuel calculations begin. And we actually ended up extending the length of this tube and also changing the diameter of the tube coming into it so that the transition was as smooth as possible to make sure we had as little turbulence as possible, as little confusion in the air, shall we say, when it gets there. And it's even important which way it's clocked because of the way that the airflow goes through. And the better data we can get here, the better we can tune the rest of things. Everything else keeps going happy. I mean, when you're putting together an intake kit on your turbo, you can spin that all over the place if you want to, but if you want to do it right, it's got to be this location. So in this case, it's marked. There's markings on the hoses to let you know which way up it goes. There's markings on the tube to let you know which up it goes to make sure you get it right. But that's the sort of attention to detail it takes to make sure things like the emissions testing comes through well. Okay, so part sign-off continues. We continue to sort of finalize parts as we go. We generate the final bills of materials so we can start ordering all the nuts and bolts and bits and pieces and hose clamps. And there's hundreds and hundreds of parts in one of these things from disparate suppliers. We can start bringing them and putting them on the shelf. at this point, hopefully we've got production samples. These manifolds that we're looking at right here are actual production samples from the factory. They sent them to us. We didn't sign off on the first one. We didn't sign off on the second one. We signed off on the third one, or fourth.
I think it was actually the second one.
Second one. It took a while to get this. Let's just say to get the foundry and ourselves on the same page on some of the dimensions. And once that's signed off, we had a few more parts. We could actually build another couple of cars. So we brought in a couple of customer cars, and we did the installs on theirs. And we made sure that they were different enough for what we needed. One of them was an automatic ND1, so we could test with an automatic, correct? No, it wasn't. We haven't got the automatic yet. Or we tested on a 2015, 2014, I think it was, to make sure that that's right. And that's when we use those installations to train our customer service team. They do those installations, under supervision, of course, to learn as much as they can about these kits. Because, of course, when these kits go out in the wild, they're the ones who have to support it. They're the ones, when you install one of these and you get all frustrated, you call them, they have to know enough. So we spend a lot of time training our customer service folks. We also do installation videos as part of that. We do the final instructions. We do the photography for the instructions. We do the final drafts of the instructions. Basically, this is the finalization. And then we send them off into the world. Yeah, and we also do some technical videos and product photography as well. And that brings us up to where we are right now, which is basically that's all done, and now we're just waiting for the final production parts to arrive. It's a long process. We started doing this 2 years ago, perhaps, I think. I think it's been about a 2-year process for this. Our next big project, our next big forced induction project that we have planned is going to have approximately a 2-year time frame as well. It's currently in the initial stages, the talking about, the brainstorming, the thinking. You'll see that one come up later. We'll leak it once we have something to talk about. But this is a long project. I mean, we're going to be living with this turbo kit for years. The current generation of the NA and B kits that we are running, their bones lie in 2006. So it's been nearly 20 years since we built those. We did that particular version of that kit. And there's parts on those kits that are backwards compatible ones from the 90s. So we know we're going to be living with this for a while. So that's why it's a fairly, people get frustrated that it takes a long time to design one of these kits and get them to market. But that's why, because we have to make sure we get it right. And we have to make sure that when it arrives, we have enough of them for everyone. Do we have any questions? I've been talking nonstop. It's time for you guys to take a chance.
Yeah, a question about the timeline. How long was it roughly from that first sit-down meeting, we're going to do this, to the time where you had your hard parts nailed down? How much time was that? Was that like 6 months or?
First functional car was probably, what, 8 months?
Yeah, probably 6, 8 months.
6 to 8 months, yeah, to the first running car.
Okay.
With 3D printed parts on it and
Right.
Intake hoses that are stuck together with bits and pieces. There's a lot of little fine details in these as well that come from doing them and designing and going around. These little brackets that you can see here, they're pass-throughs. You have to drill one hole, to allow this hose to get through the front sheet metal. And this, when it arrives, I can't take it off because it's part of the hose. It's wrapped around the hose right now. But it actually has a little drill guide in it. So you hold it in place, use the drill guide to drill a pilot hole, then you use a hole saw to chop the hole in, and this little thing clips in and does a nice little finish on the thing. So that's the sort of thing we spend a lot of time trying to get the installation instructions down to make it easy for someone to do. And there's some little Easter eggs in here as well. For those of you who know of the Flyin Miata Yacht Club, there's a little Flyin Miata Yacht Club logo stashed on this little plate right here. You'll never see it unless you're installing it. But you know it's there, we know it's there. Makes us happy. Brandon, do you have a question?
No, but the internet does.
The internet has a question.
The internet would like to know if we will have upgrade options in the future.
The internet would like to know if we will have upgrade options in the future. We are limited to some extent by our EOs, by the fact that these things are emissions legal. There's very few things that we can do to push it much further. This kit has been designed to run, well, currently we have power levels that we are publishing for 8 PSI. I'm going to let the cat out of the bag and say that we are currently emissions testing for 11 PSI, which would be very nice, lots and lots of power, using all the existing hardware. Future upgrades, if there are improvements that we make to the kit, we'll make them backwards compatible as much as possible. That's always been our philosophy because we know our customers stick with us for a long time. It's not a one and done situation. We're not going to sell you something and then say, I'm sorry, we changed that design last week. We're not doing it anymore. We will try to make sure that any any upgrades that we do come up with in the future are backwards compatible, because I mean, that makes our customers happier, and that makes our lives easier, and everybody wins. For example, the downpipes that are on our current NA and B kits are backwards compatible all the way to your old Bell Engineering kit from way back in the day, from the mid-90s. We made sure that they were backwards compatible all the way back there. So any upgrades that become available, we'll make sure that they can be applied. Anything else? No. I'm sorry I didn't have more pretty pictures to show you. I'm used to doing sort of stand-up, yapping away videos, like kind of what we're doing here, so it didn't quite happen. But I hope that gives you a little bit of an idea of what's involved in trying to come up with these kits. I mean, you guys get to come through and see what they look like on these pretty stands in our booth, but you don't always get to see how they got there. Yeah, even in this kit, one of the things we had to take into account was the stock catalytic converter lives here. It's got to stay here. So how do we integrate that into the downpipe? And we've come up with a couple of different ways to do that. One allows you to take your existing cat and chop the top off of it, which sounds terrible, but we have a little flange that welds on the top. It's got some self-alignment built into it, and it also has some flexibility in terms of where it can go. Or we can sell you a catalytic converter or a downpipe that has a complete cat, brand new Mazda spec in it already, to make it a little bit easier to install. But even just coming up with the way to make sure that that cat get hot enough, that cat is well supported, there's enough adjustability in the bracket to make up for slight variations in welding. It's a fun challenge. It really is a fun thing to do. A lot of time sitting in front of a computer pushing pixels. As you can see, some of our guys are really good at 3D modeling. You need to come up and have a look at this crazy looking turbine. I'd never be able to draw that, but the turbine outlet casting. And actually you can see, if for those who are interested in installation, if you look, I just noticed it, there's a slot here to allow for wrench access on the back side here for this, for this one particular nut. Yes, Brandon?
You're right, but that's actually Rev 1. Rev 2 has more clearance.
Rev 2 has more clearance, yeah. This is an early one because this was the first one that got printed. Yeah, but there's our little clearances around here. And then we try to install it and say those need to be bigger. So now they're bigger. All right, yes?
For the air filter, is that your guys' design, or is that just some other manufacturer? Okay, is it interchangeable with air filters as far as like the diameter?
So the air filter, the actual choice of air filter itself, this was chosen partly because it's a common part with our other turbo kits. Okay. There's not a lot of science to the actual air filter itself in terms of sizing and that sort of thing. It's got to be big enough. It can be too big. It doesn't really cause a problem. So in this case, we went with what was on the shelf. It's a 2 3/4 inch ID, I believe, on the fitting. So if you did have another favorite air filter, if you like green ones or blue ones, or
is that like the standard kind of size 2 3/4?
you should be able to find it. I don't know how standard it is. For us, it's standard because we use it on other turbo kits.
Yeah.
And it's a good size for the power levels we're dealing with. You could probably find others if you wanted to use something different. And this is encased in a cold air box as well, because one thing we discovered in our testing with the air filter testing is that the cold air box made a significant difference in intake air temperatures. Do you remember any numbers, Brandon?
I don't remember numbers, but actually with the air baffle, the temps were really pretty high, and then we put a lid on it, and the temps came back down to ambient.
So the baffle was just a vertical fence that went around the edge of it, but left the top more or less open. And we had to put a lid on that and discovered there was a big drop in air temperatures, which takes less, takes a little bit of load off the intercooler, it takes a little bit of load off the cooling system. It's amazing how much that goes downstream. So that's where the instrumentation came from. But the actual filter itself, it was mostly just, we have it. So parts commonality helps the warehouse.
The filter is actually custom to us, but like he said, it's common with the NA and B filter. So there's an angle on it, whatever. But
Is this this is the tilted one, isn't it?
yeah, exactly. So you might struggle to find it online, just kind of wherever, but it was very easy and available and appropriately sized for us.
And well proven. We've been using these filters for a couple of decades by this point, so
Yeah.
we know they work well. You had a hand up, Brandon.
I did. What kind of temp increases have you seen in the engine bay?
So the question is about temperature increase. What kind of temperature increases have we seen in the engine bay? And that's a little bit of a tricky question because the temperatures in the engine bay aren't that important. What's important is the temperature of the fluids coming out of your heat exchangers. If it's hot in your engine bay, as long as you're not overheating something, that important. And we spend a lot of time, because this turbocharger is very close to a plastic valve cover, we spent a lot of time with heat shielding trying to make sure that that was properly insulated. And there's also some brake lines along here. We spent some time making sure the brake lines were properly insulated as well. The end result ended up being a custom formed turbo blanket that goes down about this far.
Yes,
Yeah, it
it actually
goes-
wraps around the manifold outlet for
Okay.
the front right brake line.
All right, so it wraps around all over the place, and we ended up doing a custom cover for that, and spent a lot of time on track with temperature-sensitive stickers on the valve cover, because we had, thanks to our Ford friend, we had some ideas what the melting point of this thing was. We didn't have to find out the hard way. And we made sure that we stayed below that, and we have found even on hard track use, this is staying cool enough. We're not reforming our things. But the actual temperatures in the engine bay are not as critical as the temperatures of what's coming in and out of the engine, because we want to keep these things cool on track. And so that's what a lot of our track testing is for, is not just to make sure things don't crack, but also to make sure the car can run cool enough that you're not going to have to cut your 20-minute session short. Brandon, do you have another question?
Yes, how much power will a stock 2-liter make?
How much power will a stock 2-liter make? They make 135, 140 horsepower at the wheels on the dyno. I know they're rated for, was 155, I think, 178, all these numbers. They make about 140 at the wheels on the dyno, so this particular kit, as it sits right now at 8 PSI, is good for about 110 horsepower over stock. It's a good little increase, and it's a very torquey setup, very responsive. In fact, it's so responsive that we decided to offer 2 different sizes of this particular housing based on test driver feedback, because it was almost too responsive for happy track driving. It seems hard to believe, and I'm someone who believes in high compression engines with ridiculous throttle response, but I was one of the people who said this is just a little too responsive, so we have a larger version available for those who spend more of their time on the track. It cools a little bit more. It has more ultimate power potential for those who want to go their own way. And it also just dulls things a little bit, so a little bit easier to manage on track if that is a challenge for you. Yes?
Yeah, what is the base weight of the turbocharger?
What is the base weight of the kit?
How much weight is that?
Well, that is 110 horsepower with the weight.
Yeah.
We haven't actually measured it yet. That'll be part of the last step when we get to the shipping, because that's not been critical.
Okay.
I mean, these parts are heavy because they're cast iron, because they have to be cast iron.
Yeah.
But you're also taking off a cast iron exhaust manifold to put them in there. Actually, no, it's tubular, isn't it? Yeah. There is a weight gain. I think the shipping weight on these is probably going to be somewhere around 80, 85 pounds. There's some parts get taken off, some factory parts, but there will be an overall weight gain, but it's your power to weight ratio will improve.
Yeah, of course.
I think that's fair to say. Yes?
Do we have to have a turbo timer? Is it about each zone?
So the question is, are turbo timers still necessary? Those come from the days when turbos were only oil-cooled and not water-cooled. The danger was if you pulled in after a hot track session, you didn't do a cool-down lap, you could coke the oil in your bearings and basically clog up your turbocharger, need a turbo rebuild. That is a remnant of the old oil-cooled turbo days. With water cooling, you get what's called thermal siphoning, which once the engine's been turned off, first off, you've got water cooling to help cool down, keep the center, I forget what it's called exactly, the center section of the turbo at a reasonable temperature, as cool as we can. But also, once the engine's been turned off, it starts pulling water up through there and back out if you have it set up correctly. And that helps protect the bearings, helps cool down the oil that's in there, and prevents coking. And we have designed this, obviously, with the thermal siphoning in mind, make sure the angles are just right for the turbocharger. The clocking of the center section is actually very important. We made sure to follow Garrett's best practices for that, to make sure it would siphon properly. And in our experience in the last 25 years of selling water-cooled turbos, it's not an issue anymore. I would recommend, though, if you're street driving, drive the last mile as if you're in your own neighborhood. Drive like a respectable member of society. Don't come screaming into your don't come screaming into your driveway at full boost and then dive out of the car. And that will basically be all you need to do. And everybody will thank you, including your neighbors. Yes?
Other than the location of the cat and retaining the soft cat, what are the major carb, obstructions in getting carb certified? process, what's the hardest part?
So other than maintaining the question is, I'm repeating this because the people on the internet can't hear you. The question is basically, other than retaining the factory cat in the proper location, what are the big hurdles, I guess, to getting CARB paperwork or an EO? And I've got to say that paperwork is a big part of that. It has to be very precise paperwork. It has to answer all of their questions, and there's always a lot of back and forth on that. So that is that big part of it, is just making sure the application is set up well. And we're a member of SEMA. SEMA is not just a big show in Vegas happening next week. SEMA is also the Specialty Equipment Manufacturers Association. They are there to help people like Flyin Miata navigate that sort of thing. The lab that we use for doing the testing is a SEMA lab, and they have a couple of emissions specialists on hand that help us through that process quite a bit. In terms of the technical aspect of things, the big part of it is making sure that cat lights up when it's supposed to, that it gets up to temperature. We don't want to absorb too much heat into the turbocharger. We want to make sure it gets into the cat. A lot of that is got to do with the calibration of the tune to make sure that it is pumping enough heat in when it needs to and keeping the heat low when it needs to keep that cat healthy. I mentioned earlier that the flow through the mass airflow sensor is very important because that gives you your information that you're basing everything off. If this is turbulent, you're going to have noise in your data. You can't get the accuracy you need. That is the bulk of it, is making sure basically you've got good data, making sure you're taking care of your cat, and just making sure your calibration is good. That's the most important things. Brandon has another question.
Can you clarify the actual number that it made at 8 PSI?
The actual power number it made is 250 horsepower at the wheels at 8 PSI. And that was on an ND1. For those of you who are interested, this will fit ND1 through, NC. NC1 versus NC3, so all models of NC Miata, but that particular test was done on an NC1 with a stock exhaust system and the smaller of the two turbine housings.
That baselined at 133 horsepower.
It baselined at 133, so that particular car went from 133 to 250. So there's our increase. Yes?
Yeah, do you have to change the injectors?
We do change the injectors in this case, yes. And the fuel maps are rescaled to map those injectors, and that's because these injectors, we wanted more headroom than these would provide. So in order,
Also include the fuel pump?
nope, the fuel pump can remain the same. The fuel pumps can handle the extra flow. We run into trouble if we ask them for extra pressure. So back in the old rising rate fuel pressure regulator days, way back, at that point we had to upgrade the fuel pump because the stock fuel pump couldn't manage the pressure we were asking of it. But we're just asking for more flow, and there's enough headroom in the Mazda pumps for that extra flow.
Are the injectors included in it?
The injectors are included in the kit, yes. Yes?
You mentioned that the manifold needs time. What's the reasoning behind that?
Why does the manifold need to be cast iron? So there's two ways to build turbo manifolds that you usually see. Well, there's three. You either make them out of tubular metal, welded together, or you make them out of cast iron. And there's a lot of heat in a turbo manifold. They're 1,400 degrees, I think, is what they run at. And so they expand, they grow, and then they shrink down again when they cool, and they expand and they grow. And if you make them out of tubular metal, they have a tendency to crack. Partly because the actual welding together gives you heat-affected zones that are weaker, partly because it's probably not able to grow properly. So the big reason their cast manifold is just straight up durability. And that's the same reason you can see there's slots in here as well. And those slots are there to allow that flange to grow and contract slightly. Even though it's clamped down tight, this thing will grow. If you don't put those cracks in there, you will start cracking runners. It's amazing the amount of growth that happens in these things at 1,400 degrees, but I suppose all of us would probably look in a different shape if we got up to that temperature. Is that, okay. Yeah, tubulars are easy to make if you're a small shop doing one or two at a time. The one thing about tubulars is that there's low investment, I guess you could put in them. You can do one or two, but they do have a tendency to have a very high mortality rate just because of their fundamental characteristics. Yes?
More general question, not just about the NC kit. Is it hard to develop parts that somebody would want for their track car that also makes sense on a street car?
So the question is, again, for the internet people, the question is it hard to develop parts that are both trackable and streetable, really is what it comes down to. The answer is, in some cases, no. I mean, manifold design, it's going to be the same both ways. If you build a manifold that will handle track use, it will work on the street just fine, because that's durability in the long term. If you're making decisions on things like turbine sizes, at that point, yes, things do start to diverge, because track drivers tend to have different priorities than street drivers. Generally speaking, you use the track for durability and use the street for drivability, because track drivers rarely complain about good drivability, and street drivers never complain about durability. So you can keep them both happy. It's just, you have to make sure you're picking from the right group. Am I getting the, is the orchestra playing?
Shortly.
Okay.
The music is starting, but maybe one or two more questions.
All right.
I want to make sure to give everybody time to go to the museum, so.
There we go. Yes, there is a Mazda museum around the corner.
Before we close the building down,
Okay, good. What time do they close the building?
5 or 10 minutes.
5 or 10 minutes. All right.
We got you good.
All right, so we'll take 2 questions, and of course I will be down at the, and this model will be down at the Flyin Miata booth for the rest of the day and all day tomorrow. So let's get yours.
So on your turbo, the outlet, is that welded, that 90?
The outlet here?
No, right here, your
Oh,
outlet too.
on the compressor outlet. Yes, we did have to modify the compressor outlet on this particular kit because of packaging constraints. So we take the.
Is that a weak point?
It's not a weak point because this is not a hot side. I mean, it's warm, but it's not to the point. This is aluminum. This is not heating up to the point where it's starting to expand and contract and cause cracking problems. This is the side you've got to watch out for. Last question. Have we tried it on 2.5 engine? Not legal in California.
Have you tried it?
If your head is in the same location, should fit. We have not done any testing on a 2.5 yet. One of our employees has plans for his own personal car. But we do expect if your head's in the same location, which I think means drop mounts, then it should work on a 2.5. And there's certainly enough headroom. This is a 400 horsepower turbo, so there's headroom there. But from an emission standpoint, no. All right, well, I don't think we have any more questions. Thanks for your attention, folks. Thanks for your patience. We're here all weekend. If you do have more questions, you can come up and look at this. Just don't push it around too much or we'll have a catastrophe. And don't forget about the Mazda Museum around the corner.
Thank you.
Thank you.
I'll just say, hey, while I have your attention, just want to let you know direct.